triangle inequality theorem. So we touched on this before, which just said that the sum of any two side lengths of a triangle is greater than the third side length. So if we have different sides here, I'm just going to color code these. And it's somewhat intuitive if you think about, if you're going to make a triangle, what would the different sides have to be? If you try just drawing them and seeing what happens, you would probably come to this conclusion fairly quickly, that any two sides would have to add up to something bigger than the third side for that third side to be able to connect. Okay? So, for instance, here we would have to have AB plus BC. If you add those two sides up, it has to be bigger than the third side, which is AC. And that's true all the way around. So it doesn't matter which two sides you actually add up. So if we started here with like AC, right? AC plus BC again would have to be bigger than AB. And then a third one would be, let's see, AB and AC. Would have to add up to something bigger than BC. Now, these are in no particular order. It doesn't matter, that I put AB plus BC. It's the same as BC plus AB. A big idea is just that two sides have to add up to something bigger. Now, this is strictly bigger, not greater than or equal to. So if you had 10 on these added up to 10, and the right-hand side was 10, then that would not work as a triangle. It'd have to be 10.001, just slightly bigger. Okay? So that's what this first part is. It's just practicing exactly that. Zoom in. There we go. So we'd look at each one of these and test all of them. So it doesn't matter which order, as long as you cover all your bases. Is the first two added up to something bigger than the third, right? In this case, 4 plus 8 is bigger than 10, so that's good. And you just keep on going until you've checked everything. Is 4 plus 10, is that bigger than the third one? So yeah, 4 plus 10, that's 14. That's bigger than 8, so that's good. All right, and then last one would be, is 8 plus 10 bigger than 4? Right, 18 is bigger than 4. So since all these come out to be true, right, then you can say, yes, these make a triangle. You can draw a triangle with sides of 4, 8, and 10. It's definitely possible. You don't know the angles yet. We'll talk about that in May when we get to trigonometry. But with just this information, we can say yes, for sure. Okay? And nothing more than that. Now, if one of these came out to be false, we could stop at that point and say, okay, it's not a triangle. So if like the first one came out to be 4 plus 2 bigger than 10, and 4 is 6, that'd be 6 bigger than 10. The answer is no. You wouldn't have to check the last two. As soon as you have one of them that's false, it's not a triangle. Okay? But until we get one of them that's false, we have to keep on going. Okay. So here we'd say is, let's say 9 plus 18, is that bigger than 7? Yes. Okay. So keep going. Is 7 plus 18, is that bigger than 9, the third side? 7 plus 18, clearly bigger than 9. That's good. The last one would be, is 9 plus 7, is that bigger than 18? No, right? So you could say no because one of them turns out to be false. You can say not a triangle, even though the first two were true. Just takes one to turn it to a no. And what do you think about the last one here, C? Not a triangle. Is 5 plus 5 bigger than 10? Nope. So not a triangle. We don't have to try anything else. We don't have to keep on going. Okay. Not too bad, right? So next, using the same idea, well, if you have two given sides, what are the possible lengths of x? Now, assume these are not drawn to scale, right? This is just any triangle with sides 10 and 12. What are the possible values? What's the smallest possible value that could be? And what's the largest possible value that could be? Okay. So here's what we do. We use the triangle inequality. As long as we get a positive answer from it, we're going to use it. So we can say something like this, is these two have to add up to something bigger than 12, right? So x plus 10 has to add up to something bigger than 12. And these two have to add up to something bigger than x. And if we just go through and solve these, we'll get the two numbers. So x would have to be bigger than 12 minus 10, which is 2. And then here, just simplify the left-hand side, and we'll have 22 is bigger than all the answers, all your x values. Which, if you recall, that's the same as saying all your answers have to be less than 22. So x has to be bigger than 2, smaller than 22, which kind of makes sense. If you can imagine this angle right here getting smaller and smaller, this would be coming down, and it'd be right here, and a length of 12 would put it 2 bigger than 10. So that would be, makes sense that the smallest one would have to be a little bit bigger than 2. Otherwise, the angle would be 0. And if you said this went all the way that way and basically made a 180-degree angle almost, it was like kind of like this, it'd be 10 plus 12, 22 large. So if this was a 179-degree angle, it had to be something a little bit smaller than 22. Now, there's a special way, you might have come across this last year in algebra, that we write the between. So when an answer is between two numbers, we use this format. Okay. Less than, x, less than. Those are two less than signs with an x. And then we put the smaller number on the left, the bigger number on the right. So the newest thing of all of this might be just that format and writing your answer that way. Okay. Right here. Okay. And all this means right here is x is between. Two and 22. And it's just a fancy way of writing it. Okay. Now, there's all the algebra and a big explanation, but can you see a fast way to get the answer of 2? Yeah, subtract these two numbers. 12 minus 10 is 2. Can you see a fast way of getting 22? Add the two numbers. So basically, you subtract the two numbers, that goes on the left, add the two numbers, that goes on the right. As long as you're writing your answer in the proper format, you're good to go. Okay, and of course you know what it means, that all the numbers between 2, but not including 2. So starting at 2.001, going all the way up to 21.9999, those can all make a triangle with sides of 10 and 12. As soon as you go 2 or lower, or 22 or bigger, it's impossible to make a triangle with the sides of 12 and 10. Okay? So same idea here if we want to cut to the chase kind of fast. All right, so your answer is going to be this. X is between, and what two numbers? 15 minus 15, 0. So it has to be bigger than 0. 15 plus 15, 30. It has to be smaller than 30. So 0.001 to 29.999 would make a triangle. And we could, of course, prove that all by doing the actual inequalities. No, not really, as long as you understand the concept. But just know that it's not magic, and there is a way to prove your answer if somebody required it. I know a lot of state tests, they want you to, explain your answer. How did you come up with that? So if you know how to, where it comes from, it's okay not to show it every single problem with me. Okay. And go ahead and do the last one, see what you get. Okay, there we go. There we go. There we go. Okay. So not too bad, right? Just had to fix some signs there. And then the last part is something we've already done. We kind of talked about that briefly already here. Okay, which basically says if two sides of a triangle are not congruent, then the largest angle is opposite the longest side. So large angles are paired with the longest sides, long sides there, and vice versa, which we'll do on the other side there. So if you have all three sides of a triangle, you don't know exactly yet what those angle measurements are, but you know which one's definitely the smallest. So you find here of 15, 12, and 10, you know that 10 is the smallest, so opposite of 10 would be angle C. So angle C would be the smallest angle of A, B, and C. And likewise, of 15 and 12, 12 is the next smallest. We'll call it the medium, right? So this is the medium. Across from or opposite of 12 is angle A. So angle A is in the middle or the medium. Right? And lastly, we have the largest side, which is 15. So across from 15, opposite of 15 is angle B, which would be the largest angle. Okay, so if I was going to put these in order from least to greatest, I'd go angle C. Right. In the middle would be angle A. And then the largest would be angle B. I did it again. Angle B. There we go. Okay. Now, it's not necessary to actually write all these lines and everything. If you can visually just look across from something, that's perfectly fine with me. Thank you. Not here. Now, another way of looking at it, like how do you know what's across from it? Well, if this is segment AB, let's say going back here, if this is segment AB, the angle across from it cannot have the letters A and B contained in it. So across from AB would have to be angle C. Across from BC would have to be the letter that's not B or C, which is A. That's another way of looking at it and make sure you get the right letter. So from here we can see of all these, AB is the smallest. So what letter is not A and not B? C. And that's what's across from AB is letter C. And the next or the medium would be AC. And what's not contained in AC? What letter is not A and not C? That would be angle B. Okay. And of course, if you have the first two, the largest would have to be the last one. In this case is angle A. Okay. So without actually drawing the letters, you can still get all the same answers. All right. Okay. And on the back side, same idea, just with the converse, really. It's the converse of the front side. So if two angles are not congruent, then the longest side is opposite the largest angle. So we can do the same idea here that we just did, just in reverse, right? So instead of finding the smallest side, find the smallest angle and go across from there. So we have the smallest angle here would be 30, which is angle A. So opposite angle A would be, of the three letters, take out A. So you're left with BC. So BC would be the shortest length. And then we can continue that. Find the next smallest would be angle C. And if you have ABC and you take out letter C, you're left with just AB, which is across from. And then lastly, largest angle is angle B. If you have ABC and you take out B, you're left with AC. All right. And I think on all the questions, it's usually least to greatest, but double check the directions just to make sure it doesn't say greatest to least, because you can have all these correct and just have them in the wrong order if you don't read the directions carefully. All right, so one more and we're done. So looking at this, see if you can try it on your own. If not, just watch up here. My smallest would be here. Opposite would be that. All right, and my next smallest or next largest would be here. Opposite of here would be here. And lastly, our largest angle is here. Opposite of that angle is here. Okay. The last part, definitely intuitive, but even the first part with the triangle inequality. Here is pretty intuitive. You can just imagine the angle between the two sides given getting smaller and bigger, and they have to be bigger than some number but smaller than another in order to make a real triangle. All right, so you guys have the rest of the period to do that. On the last page, there is a just review of all the different types of angles here. So I know the format and how they're writing it is kind of odd here, but I'm not too concerned you have all the little things filled in, but that you know that something like this, you know, like what kind of angles are these called again? And then the same position on different lines. Those are corresponding. So I'm more concerned that, number one, you know it's called corresponding, and that corresponding angles are congruent, okay? So if you want to just leave out this part here. Just put corresponding or the name of the angle and if they're congruent. And of course, something like here, if you go down, these are alternate, same side interior, not alternate, but same side interior. You might need to go back to your notes to remember all this good stuff. And those are not congruent, right? You should probably look at these and see, well, this is an acute angle, this is an obtuse angle, so don't say they're congruent, when clearly the picture says they're not. So these are, if they're not congruent, you probably remember then they must be supplementary. So they add up to 180. So, and then just go through below, do the math, the algebra, and all these just ask to solve for x, I believe, okay? Yeah, same thing down here, just saying what kind of angles, what's the name of the angles, and if they're congruent or supplementary. That's the most important part. And if you recall, when we did this, it was easier to remember which ones are supplementary, and remember that one that's supplementary, and everything else was congruent. Okay, that was the easy way to keep track of all that. Okay, all right, you got the rest of the period. Do what you can do to get done, and tomorrow we just start reviewing for your test.